Okay, so we've looked at making soap from triacyl glycerides. In this video, we're going to see how biodiesel is made from them. Okay, so once again, I'm going to draw my triacyl glyceride, and I'm deliberately not starting the video with it already drawn on the screen because I want you to, to realize drawing it lots of times is how it's going to make it stick in your mind and thinking about where all the bits come from. So yeah, we've got our, comes from the propane, isn't it? The propane 1,2,3 trial. So you've got 3 OH groups. So 2 hydrogens on that carbon, 1 hydrogen there, and 2 on that one. Unlike what I said in an early video where I had 3, 2, 3, made a mistake there. So now we need to draw the rest of it. So let's do it in a different color. Let's have so this is come from the carboxylic acid. Okay, so that's R1, and don't forget R is going to be a long fatty acid chain, and it's going to be R will be an odd number of carbons on it because the overall thing has got to be an even number of carbons. Remember, it's always 14, 16, 18, or 20 carbons long, the fatty acid. So that's R1, and this fatty acid doesn't have to be the same as that one in the triacyl. So it can be slightly different. This one might be, it's only 16 long instead of 18 long. And then R3 could be different again. Maybe that's got a double bond in that one or something. Okay, so there's your triacyl glyceride. And what happens is, what you do is you react it with methanol. Okay, so you need 3 methanol molecules. So for that, do that in red. So you've got 3 methanols there. And what's going to happen is you're going to break the ester linkages here. And you're going to stick a methanol on to this carboxylic acid. You're going to stick a methanol to the left of that, break the ester linkage there, stick the methanol there, break an ester linkage there, and so on. Okay, so let's draw that. So we're going to get, let's draw this first one, R1, carboxylic acid. So you get R1, and I'm drawing it backwards there, which is illogical, so I won't do that. I'll draw it. So you're going to have R1, R1, and this is the carboxylic acid bit here, and that is forming an ester now. So that oxygen's come from methanol, so that's called a methyl ester. Okay, so we need to form that one. This R2 is going to be very similar there. We're going to have R2, and then with R2, and we'll have the methanol there, so that's another ester linkage. And then finally, we're going to have the third carboxylic acid, R3. Third methyl ester. So you've got 3 methyl esters. And of course, we've got to remember what happens to this bit here. Well, that is going to form propane 1,2,3 triol or glycerol. So I should draw that. Okay, it's going to have the O, and the H's come from the methanol here. Okay, so it's now not an ester anymore. It is going to be, in each case, an alcohol group. Okay, and just put the rest of the hydrogens on there, H2, H, H2. Okay, so that is propane 1, 2, 3 triol, and don't forget you need the E here, or glycerol. If you ever see glycerol, it's a very thick, viscous liquid because obviously having 3 OH groups, it can form lots of hydrogen bonds, and they put glycerol in shampoo to make it thick, and so when you pour it in the palm of your hand, it just doesn't run off and be watery, they've always got, that's the thickness is because they've got glycerol in it. And these are all methyl esters. Okay, you've got 3 methyl esters. Okay, and I've done the methanol in a different color there because it's if you didn't look very carefully, you could think, oh, let's look at that and let's look at that. Or what you've done is you've broken the bond there and broken the bond there somehow. Well, you haven't broken those bonds at all, have you? You've chopped off the whole black bit here, the whole propane 1,2,3 triol, and stuck on 3 separate methanols there. Okay. Why do they do that? Why do they get the triacyl glyceride and turn it into methyl esters? Well, the molecular weights are going to be low, as we said in the previous video, and that will mean it be less viscous, the diesel, and it will have a lower boiling point. It will burn at a lower temperature. Okay, so that is making biodiesel. Okay,